Welcome to AI with Fizzy. Welcome to Machine Learning Mondays. Today, I'm going to walk you through another powerful model called Multiple Linear Regression. Now, this is a really good model, and I'm going to show you two parts of it. The first part I'm going to show you is more tailored towards the Premier League football players that we've currently been doing for the past few weeks and how well it's been performing there. And I'm going to show you another part using a different data set where I'm looking at 50 startups. And I want to show you this to kind of show you the good as well as the bad. When you're doing R2 scoring, based on your feature engineering, based on your future data sets, when you have a really good data set that benefits the model, you'll see a really good R2 score. When you have a data set that doesn't fit the model in its use, then you see a really bad R2 score. I'm going to show you both of those views so you get an idea in terms of what to look out for, as well as, again, showing you the really good importance of testing various different models to find a really desired outcome, which is not only finding a model that fits the purpose for what you're trying to achieve. And in this case, we're trying to achieve, what's the predicted market value of 2,000 Premier League football players over the next 2 years. And also the R2 score, which is really important. And I will encourage anyone who's in machine learning or trying to learn the machine learning, like myself, to leverage mean squared error as well as R2 score in every single model that you've built, because it gives you an indication of how high performance your machine learning model is actually, computing the right results. And again, it just makes it look more valid than it actually does. So check out this quick video that I'm going to walk you through in terms of what IBM's definition of multiple linear regression is. I'm going to walk you through two data sets and two models in machine learning. And then, you're going to see how it works really good. And you're also going to see how it works really bad. Stay tuned. And here's the video.
All right, cool. So let's go through MLR, multiple linear regression. And I thought today I'll walk you through the IBM definition of it. It may sound a bit technical, but I will numb it down and give like a summary view. However, I just want to walk you through MLR itself and also how we're incorporating it into the model for Premier League football players. So let's start off with the IBM definition of what MLR is. According to IBM, multiple linear regression model is a versatile statistical model for evaluating relationships between a continuous target and predictors. Predictors can be continuous, categorical, or derived fields so that nonlinear relationships are also supported. The model is linear because it consists of additive terms where each term is a predictor that is multiplied by an estimated coefficient. Constant, which means intercept term, is also typically added to the model. Linear regression is used to generate insights for charts that contain at least two continuous fields, with one identified as the target and the other as a predictor. So quite a lot to kind of walk you through there, but in a nutshell, think of it as a way to predict a number. And let's take the player salary, for example. So by looking at the impact of several factors, for example, their goals, assists, how many minutes they've played, for example, the goal contributions through future engineering that we've done, it works by adding up all of those factors, and then it sees how much one contributes to the final number. So even though it's kind of called linear, you can still use it in different types of data, like numbers or categories, as long as you prepare the data properly. And I'm going to walk you through quickly two examples of multiple linear regression where one, it just doesn't work and it can cause huge harm to your model. And I'll show you through the R2 score of how terrible it was. And then I'll give you a really good example of how MLR is really good and efficient with a high R2 score. So let's go back into the Premier League football players. And here I've built an MLR model where I've actually imported the libraries that I needed. For this particular ask, I've just excluded all the feature engineering. So normally we would have the goals per minute, goals contribution. I've excluded those out. And then what I've also done is basically include the X data set and the Y data set. Here you would see there is a small error here, so this needs to go. Goals per minute and goals contribution. And then I've got the X train, X test, Y train, Y test. And I've also done the one-hot encoder. For example, remember the positions column has string inputs inside. So for example, think of forwards, defenders, goalkeepers. You want to convert that into a numerical value because that's how machine learning model works. And then here I'm just training the model, calling the linear regression. And then here you can see what I mean by the R2 score is -7, which is absolutely terrible, which lets me know, first and foremost, more feature scaling or feature engineering needs to be imported, or I need to revisit the data. It's probably, it can't find the right kind of factor to kind of determine what the number should be in multilinear regression. So this is a really, really example of way in terms of where I say, it's best to always test your model. It's best to always ensure that you try different models for different use cases. Reason is, if you just went to multiple linear regression and thought this is, the output without scoring it, it's going to look very, very bad in this case. So things that I've learned is, again, look at your features, look at the data, and then reapply that, and then check the R2 score afterwards. But I do want to show you quickly what a good multiple linear regression is. So same thought process here. This is based on 50 startups. So I've basically called in this code here, basically calls in, give me everything, but remove the last column, which has all the values. And I want everything, but include the last value. I don't want everything, but the last values here. And then same process, same everything. But then here you can see the R2 score is incredibly high, 93%, which is great, which means the model is working very well. But just to show you what I'm pulling in,
there you go. You got to see how bad when you have a model and you're putting it into your data set, you test it and you run it, you can see how bad the results can be, which gives you an indication of, the features just doesn't bode well with the model. You may need to rethink how you actually set up the features. In my case, maybe the features that I'm currently having at the moment, it's just making it overfit and it's just not suiting its purpose. So I need to revisit the data that I'm plugging in. And also you get to see from a really good perspective on a data set from 50 startups, how really good and powerful we can trust the machine learning module, because it's given us 93% as opposed to -7% when we're looking into the Premier League football players. So you've seen various different models over the past few weeks dish out different scoring methods, whether you're adding feature engineering or whether you're excluding feature engineering. The long story short here is basically you'd want to always test various models. If you can, test them all, but at least pick 4 or 5 models to test from as a base minimum to then give you the best outcome in terms of what you're trying to achieve. So we've gone through various models so far. There's one more I want to show you, and I'll save that for next week until I show you a final video where I've actually done the hard work in the background of feature scaling, feature engineering for all the models that will actually improve the R2 score. Yeah, I just want to say thank you so much for joining me in my machine learning kind of series, episodes, whatever you want to call it. I've really appreciated the love and support. I'm still a student in the game. So again, feel free to point me in the right direction. Feel free to give me the kind of insights in terms of what this actually does and what this can actually mean and how to improve moving forward. But alternatively, I just want to say thank you so much. I really appreciate it. It gives me huge hope just to continue on and sharing knowledge as I'm learning with you all. And yeah, like I said before, as always, stay living with AI and peace.